Hi, this is Coach Smith, and what I have for you right here is it's the study guide for the system of equations to prepare you for the 10 ready test that we are taking on Monday. So what I'm going to do is I'm just going to go through each problem and just watch the ones you need to watch and compare what you have, and if you have any questions, definitely try to get to me Monday morning before we take the test and I can try to give you help. Otherwise, here we go. When you're talking about looking at these graphs, it says, wants an example of one solution, no solutions, or infinitely many solutions. Remember, if you see on a graph and you're talking about systems, you're talking about more than one equation. So you're talking about two different lines that are going to be graphed. So if I have one solution, when I graph it, it's going to kind of look like somewhere. Remember, the solution is going to be much straighter, but the solution is going to be where the two lines intersect, and it can be anywhere. So in this case, it's going to be right here in this area. That is one example of a one solution. So it's going to be one coordinate pair where the two lines actually intersect. Whereas now on the no solution, if you remember, when you're talking about systems, you're talking about where they have to intersect. Well, if they never intersect, which means you're going to have completely parallel lines, that means right there you're not going to have any solution. So a no solution should be absolutely parallel lines. Now, if you're talking about infinitely many solutions, you're talking about intersecting at every single point on the line. So in this case, I could actually do one line. It's going to actually appear that there's going to be one linear line, but there's actually two, and I'm going to use two colors, so it'd actually be kind of laying on top of each other. So it's actually intersecting at every single coordinate pair, and that is an example of system of equations graphed, whether you have one solution, no solutions, or infinitely many solutions. Alright, the first one what we have here is it says Sarah attempted to solve the equation of negative x plus 5 then times x plus 6 in parentheses equals 4x plus 30 as shown, and concluded there are no solutions. Well, and then it gives you her work, and then solve the equation, identify her error, and find the correct number of solutions. Well, there's a couple different things in this. It's not just like there's one step here. There's multiple steps to actually solve this problem. So the first thing I have to do is I'm going to look and actually solve the problem. And when I do, I'm going to go, if I look negative x plus 5 and then x plus 6 equals 4x plus 30. Well, when I do, I'm always going to draw my line of scrimmage that separates the two equations. So now, when I look and I want to solve things, I make sure I want to get rid of these parentheses first. So in order to do that, I've got to distribute. When I do that, I see 5x, so I'm going to go negative, just bring my next negative x down, and then 5 times x is positive 5x, so plus 5x, and that's what she did too, so far we agree. But then, see, 5 times 6, because in order to get rid of the parentheses, we've got to distribute through the whole thing, and 5 times 6 is 30. Well, I'm going to go ahead and stop here for just a second and look up, well, one error Sarah made is, she distributed here to the 5 to the x, but she did not distribute to the 6. She just simply brought the 6 down, whereas that's going to give her a crazy answer in the end. So, but we're going to keep on going to see what really is the right answer. So 4x plus 30. Now, I'm going to look on each side, and I'm going to try to combine any like terms that I can combine. We'll have negative x plus 5x. Well, it's like negative 1 plus 5, so I have 4x, not negative 4, but 4x plus 30, and that's going to equal 4x plus 30. Well, I automatically see here that I have the exact same thing on both sides. So now, if we follow the rules that we gave in class, go ahead and get your variables to one side. And the answer is definitely, it's just going to be right there in front of us. So I'm going to go ahead and subtract 4x from both sides. And when I do that, it's going to zero those out. And that leaves me 30 equals 30. Well, if 30 is equal to 30, that's truth. So therefore, I'm not going to have one solution or no solutions. I'm going to have infinitely many solutions because this is an identity. They are the exact same. So Sarah should have said, instead of no solutions, she should have said infinitely many solutions. Alright, the next one. To solve this system of equations, you have 4x plus y equals negative 12, and then you have 5x plus 2y equals 25. And it's asking you which expression could be substituted for y in the equation 5x plus 2y equals 25. Well, what it's really asking is here, and not that I want to mess with this one yet, it's asking what can I substitute in for the y with this one to actually make this work using the method of substitution. Well, what I got to do then, I can take the other one, because honestly it's not going to be too bad to actually transform 4x plus y equals negative 12 into slope-intercept form. So I'm going to bring it down and just rewrite that one, as it's asking what can I do to substitute in for this y. Well, we're about to find out. Well, to get y by itself, in this case, I can just subtract 4x from both sides, and when I do that, I have y equals negative 4x minus 12. So that's telling me that the y value is equal to negative 4x minus 12. Well, in this case, that tells me up here, b, I can substitute that in, and I'm going to go ahead and write what that would look like. I'm not going to go ahead and solve it all the way out, but I'm able to show you what it would look like. You got 5x plus 2, and then all you're going to do is make sure you put in for the y, you're going to put negative 4x minus 12 equals 25. Then I'm going to solve, and so then I'm going to use that to substitute back into the other to complete the method of substitution. Alright, this next one, this is the one that was kind of tricky for everybody. That I noticed probably the most common errors came from this one. Is the cost of a medium pizza at two different pizza shops is shown. Well, you have Pizza Oven, and then you have Pizza Stop. Well, so we've got to compare the two. There's so many different steps here that we kind of need to do to actually solve this one. And I'm going to show you a couple different things that ways we can rewrite this to kind of make it more familiar. Like for example, we know Pizza Stop. It's actually pretty easy. We can look at the additional toppings. For one additional topping, you're going to pay $12.50. For two, it's $13. Three for $13.50. Well, let's look at our rate of change. Our rate of change is constantly going 0.5, or say for example in money 50 cents. So no matter what, each time it's going up 50 cents. So if I got four toppings, my cost should be $14 because I'm going up by 50 cents. My rate of change, it stays constant on both sides, so I have a constant rate of change. Now here's where I noticed most people getting confused is you're talking about Pizza Oven, the other place. Well, it says C equals 10 plus T. Well, here, and it tells you C is the total cost. So I'm going to rewrite this. I'm actually going to rewrite it using X and Y to make it more familiar, and then I'll put above it what they say to put. For example, the C, I'm going to take and make my Y. I rewrite this equation, so I know it's Y equals, well, and that would be, I'm going to put a little C up here, that's my cost. Now, for some reason, on all this stuff I've seen, they've switched the slope and y-intercept. That drives me absolutely insane. But so what we're going to do, we're going to take the t, because it is t, and understand if there's just a variable, that means there's a 1 in front of it. I can go ahead and put the 1. I'm just that way to show it. And then I'm going to make my x, and above it I'll do a little t. That way we're comparing what they put to what may be even more familiar. And then that's a positive 10. So you really have y equals x plus 10 if you were talking about slope-intercept form and talking about there's your equation. So now what I want to do is I'm actually going to create my own table here using this one. So I'm going to make a different color just to be able to compare it. And so I'm going to create beside of it, I'm going to come over here, and I'm going to make my own table. And I'm going to keep it the same thing. I'm going to keep it with theirs. So it's going to be the toppings. I'm going to use, except I'm going to put T, and then I'm going to put C money right there. So now if I have, and I'm just going to compare the prices. Because what this is saying, it's saying the total cost is equal to $1 per topping. If I have one, for example, here I have 0.5, we said it's 50 cents per topping. Well, a whole is going to be $1 per topping. I've got to understand the whole scenario of the equation, or the whole scenario of the problem to know, hey, wait a minute, this is $1 per topping. So in that case, I know if I get one topping, well, I've got, and I'm just substituting in, so I have 1 times 1 plus 10. That's going to be $11. So at this point right now, and it's looking good, Pizza Oven's looking like the best. So now, because what we want to find out is, and I didn't say this at the beginning, but we want to know actually the two lines to find out where they're actually going to have the same price. That's what we're looking for in this question. So we want to be able to find out who actually has, what point their prices will be the same. So now I'm going to go back over here to the pizza oven, and then keep that one going. And then I'm going to say, okay, if I want 2 pizzas, well, in that case, if my rate of change, I'm going to go, because I know it's 1, and I put it 2. Well, 2 times 1 is 2, plus 10, well, 2 is 12. And I'm already starting to see my pattern, but if I want 3 toppings, my pizza is now 13. And I'm just going to keep going. If I want 4 pizzas, it's going to be $14. Well, at this point, by doing the table, now I know that at four toppings, both pizzas will be the exact same price. And that way, so when it asks, well, what would be the better deal, really, it all depends on how many pizzas or how many toppings you want on your pizza as to what's the better deal. But in this case, it wants you to actually graph it. And I'm going to be honest, on this paper, it is not a very good graph because it really don't give you the right numbers in order to graph it. So I'm going to leave it with a table. So if you have the numbers, when you graph them, what you're going to notice is that at the coordinate pair of 4, 14, that's where you're actually going to see that they intersect. They'll come together. And that is with this problem. So at 4 toppings, at $14 is going to be where they are the exact same price.